All right, this is the next lesson in geometry. This is Unit 4, Lesson 4, Isosceles and Equilateral Triangles. So its first definition is an isosceles triangle. An isosceles triangle is a triangle with at least two sides congruent. They are very common in the real world. You can find them in structures such as buildings and bridges. The congruent sides of an isosceles triangle are called its legs. So in the diagram below, this side and this side, these are the two congruent sides because they're labeled with one tick mark on each. So those are going to be called the legs. So that's a leg, and that's a leg. The third side is called the base. So in the diagram below, this side would be my base. The two congruent sides form what's called the vertex angle. Okay, so in the diagram below, these are the two congruent sides. So they form what's called the vertex angle. So this is the vertex angle right here. And the other two angles are called the base angles. Okay, so my diagram below, this is a base angle. And then this is another base angle. Now there are two theorems that you have to know. And these are the most important. These are the two most important things in this lesson today. Okay, these two theorems. First theorem is called the isosceles triangle theorem. It says, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So in this diagram right here, if these two sides are congruent, because they're labeled with one tick mark each, if these two sides are congruent, then it means that this angle is congruent to this angle. Okay, because the angles opposite the congruent sides are congruent. And if you think back to Unit 2, we did converses. Converses are when you switch around the hypothesis and the conclusion. So the converse of the isosceles triangle theorem is also true. Okay, so here's the converse. If you know two angles of a triangle are congruent, then you can conclude that the sides opposite those angles are congruent. So if I knew that angle E was congruent to angle F, then I can conclude that segment DE is congruent to segment DF. Okay? So those are two theorems that you definitely have to know from this lesson. It's very important that you know those two. So if you need to, pause the video and read over those theorems a couple more times if you need it. And one of the reasons why I like geometry is because you can see why stuff is true sometimes. So what I'm going to do right now is we're going to do a proof of the isosceles triangle theorem that I just gave you. So we're going to prove that theorem to see why it's true. Given that segment AB is congruent to segment CB, prove that angle A is congruent to angle C. So we're given that AB is congruent to CB. That'll be my first statement, as always. The first reason is always given. Okay. Now this is kind of a weird proof. Probably not the type of proof I would ever give you on a quiz or test. But what we're going to do next is we're going to draw in segment BX, I'm going to call it. such that it bisects angle B. So here's what I'm going to say for statement 2. XB, the segment I just drew in, is the bisector of angle B. That reason is called biconstruction, because I just drew that in myself. Okay? So I just drew in segment XB so that it was the bisector of angle B. One second. Okay, now the next thing I'm going to do in this proof is I'm going to say that since I just drew in the angle bisector, it means that this angle right here with one arc is congruent to this angle right there with one arc. So I'll say angle ABX is congruent to angle CBX, definition of angle bisector. Next, I'll use the reflexive property of congruence, and I'll say that segment BX is congruent to segment BX. Reflexive property of congruence. All right, so now I can say the two triangles are congruent. I can say triangle ABX. Okay, look how I trace it. Triangle ABX is congruent to triangle CBX. And that is side angle side. Side angle side, side angle side. So side angle side. And now, since I have the two triangles are congruent, I can say that angle A is congruent to angle C because the corresponding parts of congruent triangles are congruent. CPCTC. Remember, you use side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg when you want to prove that two triangles are congruent. When you want to say like a specific part is congruent, like angle A is congruent to angle C, that's when you use CPCTC. So that proof right there just proved the Isosceles triangle theorem that I gave you on the previous page. Okay, now on to the actual examples with numbers. Example 2, find the measure of angle F. So when you use the Isosceles triangle theorem, since this side is congruent to this side, it means that the angles opposite those two sides are congruent. So angle D is congruent to angle F. So the triangle angle sum theorem says that all the angles in the triangle have to add to 180. We know this one is 22. We can find the final two. If we do 180 minus 22, that gives us 158 degrees. That 158 degrees is angle D and angle F combined. Angle D plus angle F. These two add up to equal 158. If each one is the same, then I can do 158 divided by 2 to get each one. In that case, each one is 79. So the answer is the measure of angle F equals 79 degrees. Okay, let's do example 3. Find the measure of angle G. So again, this side is congruent to this side, so it means that the angles opposite those two sides are congruent. So this angle down here is going to be congruent to this angle up here. Okay, because these two sides are the same, so it means the angles opposite them have to be congruent also. So I'll do 3x equals x plus 44. We're going to solve that for x first, and then we're going to solve for the angles. Subtract x on each side, 2x equals 44. And then divide by 2, and you get x equals 22. That's great and all, but now make sure you actually find the measure of angle G. The measure of angle G equals x plus 44. X is 22, so 22 plus 44. If you want to double check your answer, let's double check the answer by testing the measure of angle J, because that should also be 66. 3 times x, 3 times 22 is 66, so I know it's right. Example 4, find AM. Now this one might be a little tricky. You have some extra information in this problem that you do not need, okay? So if you look at it, angle A is congruent to angle S. So the sides opposite those two angles are congruent. So it means that this side is congruent to this side. Okay? Those are the two congruent sides. Okay? Because the angles, these two angles are congruent. So the congruent sides are the sides opposite those two angles, which are these two sides. So don't do anything with this side. That's just there to try to trick you. That side is not congruent to the other two sides. So I'm going to do 6x minus 9 equals 4x plus 5. Solve that for x. Subtract 4x on each side. So 2x minus 9 equals 5. Add 9, 2x equals 14. And then x equals 7. That's great, but make sure you find AM, because that's what the question says. AM, according to the diagram, is 6x minus 9. And we just established that x is 7, so 6 times 7 minus 9. 42 minus 9 is 33. Okay, so that's how you solve for that. AM equals 33. If you want to double check, sorry, I was distracted right there. If you want to double check, you can find SM. It should be the same exact thing. 4 times x, 4 times 7 is 28. 28 plus 5 equals 33. So they both are the same number. They're both 33. So that means I'm pretty sure it's right if they both came to the same number. What are the chances of making a mistake and the mistake ends up working for both of them, so they end up the same? Very small. So I know I got it right. Okay, one more definition and one more example. An isosceles triangle we talked about earlier, that has two sides congruent. An equilateral triangle has all three sides congruent. Okay? An equilateral triangle is a triangle with all three sides of equal length. It is therefore a special case of an isosceles triangle having not just two, but all three sides congruent or equal. So since all three sides are the same, it means each angle is the same. So it means each angle has a measure of 60 degrees, because all the angles in the triangle add up to 180. If each one is the same, then you do 180 divided by 3, each one is 60. Find x. Well, each of the angles has to be 60, so I'm going to say 2x plus 32 equals 60. And again, the reason why each angle is 60 is because we have an equilateral triangle. Since each side is the same, it means each angle is the same. Think back to the first page, the isosceles triangle theorem. This is just extending that to three sides. Since all three sides are the same, then all three angles are the same. Therefore, each angle is 60. We just talked about that above. Solve this for x. Subtract 32. 2x equals 28, and x equals 14. Let's just double check that real quick. 2 times x, 2 times 14 is 28, plus 32 equals 60. Perfect. So that is the end of that lesson. That lesson was called, that was Unit 4, Lesson 4. And it was called Isosceles and Equilateral Triangles. You really have to make sure you have these two theorems memorized. We're going to be using those a lot in this lesson and in all the assignments in this lesson.